To make the robot affordable, Tesla needs to be great at large-scale production. Instead of the robot costing hundreds of thousands of dollars, the goal is to bring it down to around $10,000 to $20,000. Eventually, the octopus-like robot could be sold for $20,000 to $30,000. What's impressive isn't that a two-legged robot can move boxes or make coffee. Boston Dynamics has shown off those tricks before. What's special is that Tesla plans to do this at a price similar to a regular car. Why is price important? Because how useful something is depends on how common it becomes. An expensive robot is just for show, but a $20,000 machine could truly change how work gets done. Will affordable robots change the world or just become pricey toys for the rich? Welcome to Tesla Car World. So how is the Tesla Bot Gen 3 an AI breakthrough that fits within that budget? Tesla is using its existing manufacturing power in Fremont, Shanghai, Berlin, Austin, and now Mexico. The robot's motors, sensors, and even the 4,680 battery cells come from the same supply chain used to make the Model Y. Every small cost saving, from battery tabs to drive units, helps reduce the robot's production cost. In terms of manufacturing, Optimus isn't a separate wild project. It's built using the same parts and systems that power Tesla's current cars. Inside the Optimus Gen 3 is a 3 kWh 4,680 battery pack. Thanks to the new design, engineers could hide the battery inside the torso, removing the need for a large battery pack on the back. This change cut 22 pounds off the total weight, bringing it down to 138 pounds. Lower weight means smaller motors, less heat, cheaper parts, and better efficiency. When Tesla first revealed Optimus in 2022, the robot could barely walk. By May 2025, the third version can now grab a tennis ball in mid-air, perform a dance, and even thread a needle, all shown in Tesla's videos. This big step forward is powered by a new robotic hand with 22 points of movement, double the previous generation's 11. That brings it close to the human hand, which has 27 moving parts. Each finger is moved by cables and tendons, with sensors that can feel pressures under 1 Newton. The hand is now more accurate, going from 5 mm precision to 1.44 mm. In one video from November 2024, the robot catches a glowing tennis ball flying at about 40 km per hour, 11 meters per second, in just 380 milliseconds, without any signs of remote control. By May 13, 2025, another video showed two Gen 3 robots doing a 32-step dance in perfect sync, with their movement staying within 1 degree of what was intended for the full 47-second performance. That's a level of accuracy more common in motion capture systems than real robots. Experts say Boston Dynamics Atlas still jumps higher, but Optimus now has the most advanced robotic hand on the market. That jump in precision is thanks to a total software rewrite. Tesla replaced its older motion control system with one based on the company's self-driving software. Now, the robot sees first, then moves. 8 cameras send data to a neural network that works with Tesla's FSD, full self-driving, chip. This system creates a 3D map of its surroundings 100 times per second. That data then feeds into a controller that updates 500 times per second. The time between seeing and acting is now just 23 milliseconds, half the delay from the previous model. Even more impressive is how the robot learns. On May 29, 2025, Tesla posted a video of the robot folding t-shirts after simply watching 45 minutes of GoPro footage. No direct control, just learning from video. Tesla says this cuts training time by 70%. Gen 3 is also tougher and lighter. A teardown by Interesting Engineering showed that the robot's frame weighs 125 pounds, 57 kilograms, and uses 40 electric motors. Its 2.3 kWh battery allows it to work an 8-hour mixed task shift or walk for 4.5 hours non-stop at 5 miles per hour. At rest, it uses about 100 watts. Under heavy load, like carrying 45 pounds, it peaks around 500 watts. These numbers put it on par with the energy use of an adult human. This translates into real-world skills. The robot's grip strength has tripled, from 8 to 24 newtons. It can pick up a raw egg gently or tighten a 6 mm bolt to exact specs. In repetitive tasks, like placing parts 1,000 times, it stays within 0.6 mm of accuracy. That's similar to robotic arms that cost as much as the entire Optimus unit. Each body part has its own 6-axis motion sensor, helping the robot balance and react quickly. It can recover from a 15 kg side shove in 620 milliseconds, with only 4.3 degrees of ankle movement. By putting everything, sensors, motors, software, on a single Tesla-made chip, the robot behaves less like a scripted machine and more like a living creature. Altogether, the 22-degree hand, fast vision system, and all-day battery are reshaping what a general-purpose robot can be. Where Gen 1 just waved, Gen 3 handles wiring, restocks shelves, and solders components, jobs that require real human-level skill, not just walking. This shows a turning point. Robots are no longer just interesting, they're about to become essential. Elon Musk believes Optimus could become Tesla's biggest product ever. He even said it might be 10 times larger than anything else ever made. When people think of humanoid robots, they often imagine a sleek helper doing boring or dangerous jobs for us. That sounds great. But others worry these robots might take away human jobs or eventually overpower us, like in science fiction. Truthfully, many robots still look awkward and clumsy, barely able to stand. They get mocked online for walking like confused dancers or for being overhyped. And that criticism isn't totally wrong. Many robots today can't really do useful tasks. No wonder people are skeptical. But recently, something big has changed. We're not just seeing slow progress, we're seeing major breakthroughs. A few years ago, it was just Tesla and Boston Dynamics. Now, companies all over the world, especially in China and the US, are racing to make the best humanoid robot. That doesn't mean Tesla has already won. But when it comes to making robots useful in everyday life, Optimus could be the one to watch. On CNBC last week, Elon Musk once again said Gen 3 would cost under $20,000. He believes that once Tesla builds 1 million units a year at its Fremont pilot line, the materials and overhead cost will drop to about $10,000, allowing Tesla to sell each unit at car-level prices and still earn strong profits. For comparison, a regular robotic arm with fewer features than Optimus sells for about $45,000. Boston Dynamics Atlas still has prices in the mid-six figures. That's why Morgan Stanley estimates the global humanoid robot market could hit $5 trillion by 2050, with Tesla leading the cost race. The reaction to Tesla's price was fast. When reservations opened on May 17, 5,000 businesses signed up in the first 72 hours. A live demo from Giga Texas confirmed the demand. Logistics company GXO asked for 750 units. A German supermarket chain wanted 300 for shelf restocking. A hospital in Thailand booked 120 for nighttime linen service. These businesses operate in very different fields, but they all saw value in the same thing. At $20,000, a single-shift robot pays for itself in under 14 months, even before tax credits. Tesla's own numbers are even more aggressive. A robot working 2 shifts at $18 per hour saves $90,000 a year, while using only $2,000 in electricity. That means it pays itself off in about 10 weeks. And this isn't limited by how many Tesla can build. In January, Tesla said its first robot factory was already producing 1,000 units per month. A second factory is being built to hit 10,000 units per month by late 2025. In March, Elon Musk challenged his team to build 5,000 complete bots before the end of the year and prepare parts for 10 times that amount in 2026. Wall Street paid attention. In April, Musk told investors he's confident Tesla can reach 1 million bots a year by 2029, 4 years ahead of the original target. If that happens, Optimus will become the fastest-growing hardware product in history, even faster than the Model 3 and close to the early iPhone. It's not just about numbers. Musk plans to use thousands of these robots in Tesla factories first. That means every visitor to a gigafactory will see a robot doing real work. Analysts think that visibility will boost demand even more. Each Optimus on the floor becomes a silent salesperson. Tesla also plans to lease robots for $3,000 down and $2 per hour of use. That deal, leaked in a note from Wall Street, means even small businesses can afford one by only paying when the robot is working. Behind the scenes, the savings come from Tesla's classic playbook: own everything. The same 48-volt system used in new Model 3s is used in the bot. Unused capacity from Tesla's giant casting machines is now used to make robot joints. Dojo's massive AI chips, originally built for self-driving, now help robots plan movements in 23 milliseconds. Since Tesla owns the chips, batteries, and factories, it can offer this all at no extra cost. No other company can match that yet. The $20,000 target flips the entire industrial automation market. And the thousands of early orders show this isn't just hype, it's real. If Tesla pulls off this plan, Optimus Gen 3 won't just be a hit product. It could become the basic worker of the modern economy. For the first time ever, a robot will cost less than the yearly salary of a person it replaces. SpaceX also sees this robot as part of its Mars plans. The next launch window to Mars opens in late 2026. On May 30, 2025, Musk said the first uncrewed Starship would launch with Tesla robots as the crew. This would happen even after the 9th Starship test ended in failure just 2 days earlier. For Mars, the robot will have a special suit made of Kevlar and other materials to protect against dust and radiation. The outer shell will be swapped with carbon fiber panels lined with aerogel to keep the inside warm without using heaters. Its first jobs on Mars will be tough: set up solar panels, run cables, connect Starlink dishes, and build landing pads using local dirt bricks. Musk thinks 30 robots working 2 shifts could finish a 100 kilowatts power station and a 1,000 square meter landing area in just 90 Martian days. That could shorten the time needed before astronauts arrive. So, could a $20,000 robot really survive on Mars better than a trained human? Let us know in the comments. Thanks for watching this video. If you want to learn more about Tesla vehicles or the Tesla bot, make sure to like, share, and subscribe to Tesla Car World. Turn on the notifications so you don't miss our next update. We appreciate your support and hope to see you in the next one. Goodbye.